Hey guys, Mr. Zigner. We're going to be looking at angles of triangles today. So triangles are really important in math. In fact, when you get to high school, you'll see there's a lot of discussion about all kinds of properties of triangles. But we're going to take a look at two of those important rules today. But before we get into this, one thing to understand is the difference between interior and exterior angles of a triangle. Interior angles, right here, would be the angles inside of the polygon. Kind of makes sense. Interior, you're inside your house. Exterior angles are formed, well, if you were to extend the lines of the sides, angles are formed on the outside of the triangles. So here we go. The angles outside the polygon that are adjacent, meaning next to, the interior angles are called exterior angles. All right, so we have exterior angles and interior of our triangle. And here comes our first rule. And some of you may already know this one. The sum of the interior angle measures of a triangle is 180 degrees. So here they labeled this one X, Y, and Z. So X plus Y plus Z is always going to equal 180. Now, I did grab this little website. Let me just show it to you real quick. Here you can see we've got the three angles of this triangle. And those three numbers currently add up to 180. Let's see if I can move this triangle around. Grab one of the corners, and there you go. Now, you can see the numbers inside the triangle changing. However, you see what's staying the same? The 180. No matter what I do to this triangle, stretch it in all kinds of weird directions, same three numbers, well, not the same three numbers, three different numbers, but they continue to add up to 180. Let's turn this into a obtuse triangle. There we go. So again, no matter what, the angles always add up to 180 degrees. All right, let's keep moving. So here I got myself a little example, and let's see if we can solve for this missing angle here. If you recall the formula on the previous page, it was X plus Y plus Z equaled 180. Except this time my three angles are X plus 110 plus 30. And you remember what that equals? Yep, 180 degrees. Alrighty. Let's combine our like terms here. So that would be X plus, what's 110 plus 30? Well, that's 140. Still equals 180. Let's isolate this X by undoing this plus 140 with a minus 140. Whatever you do to one side of the equation, do the same thing to the other side. And what are we left with? Well, this cancels out, and X equals 180 minus 140 is 40 degrees. There we go. So this missing angle must be 40 degrees. Okay, let's see what else I've got. Oh, a slightly harder example. Now they've got little expressions here for these two angles. But once again, we should add these three up, and it should equal 180. So now we have X plus X minus 35 plus this 43 degree angle. And that has to equal 180. Alrighty. So let's see. X plus X, well, that's 2X. And now what's negative 35 plus 43? If you remember adding with integers, really this turns into a subtraction problem like 43 minus 35. Okay, now let's regroup here. So that would be 13. This would be a 3. 13 take away 5 would be 8. And then 3 minus 3 is nothing. So really we have two x's right here plus 8 equals 180. All right, we've simplified this. All right, let's subtract the 8 from both sides. This cancels out. Bring down my 2x. And that now equals 172. Okay, but that's what 2x equals. Let's divide by 2 to find out what just regular old x equals. X equals half of 172. So that's 86. Okay, so are we finished? Not quite. Let's label each of these angles. Well, we know this one's 86. degrees. We already knew this one was 43. But what about x minus 35? Well, we know x is 86, so it would be 86 minus 35. All righty. So 6 minus 5 is 1. 8 minus 3 is 5. So I just got 51 degrees. So it looks like this angle is 51 degrees. But why don't we check that to make sure that works out? Let me bring this calculator over. The other thing we know is these three angles need to add up to 180. Well, let's try it out. 86 plus 51 plus 43. Yep, 180 degrees. Looks like we have all three angles properly labeled. Okay, we'll move on. Okay, I highlighted number 1 here as an example. This is actually from my students' worksheet they have to do, so pay attention. Here's one of your answers. All right, so again, our three angles have to add up to 180. Let's see what they gave us. They gave us an X. They gave us this box here. Do you remember what the box means? That's 90 degrees. That indicates a right angle. Plus this 32. Okay, and of course, that's supposed to equal 180 degrees. So let's simplify here. X plus, well, what's 90 plus 32? That's 122 degrees equals 180. Subtract the 122 from both sides. Do the same thing to both sides. That cancels out. And x equals, well, let's see here, we can regroup. That would be a 7. This would be a 10. 10 minus 2 is 8. And 7 minus 2 is 5. And up there we go, 58 degrees. Why don't we check that real quick? Make sure it adds up to 180. So we had 32 plus 90 plus this 58. And yep, perfect. We got 180 again. So we know our 58 is correct. All right, I also highlighted this one. So let's see here. Now we have two x's. So x plus x is 2x plus our 50. And again, it always equals 180 degrees. Subtract our 50 from both sides. And we have 2x equals 180 minus 50 would be 130. Divide by 2. Divide by 2. That cancels out. And x equals half of 130. Do you know what half of 130 is? 65. There we go. So 65 degrees. Now let's get that into our triangle. Well, this one's an x, so this one's 65 degrees. Here's another x, so this one's 65 degrees. Again, let's just quickly grab the calculator and make sure that works. So 65 plus 65 plus 50. Does that equal 180? Yes. All right, that verifies we got this one right. What else? Okay, now here is another rule, and I thought I would use this to introduce it. Okay, well, first of all, in this triangle, this obtuse triangle here, just let's not worry about the letter z yet, but x plus y plus z, I'm sorry, w plus x plus y. Okay, there we go. What do the three angles have to add up to? W plus x plus y have to equal 180. Okay. And now over here I say, well, what's w plus z? Okay, w plus z, that would be these two angles. Oh, did you see what I did there? I created a straight angle with w and z. Do you remember how many degrees a straight angle is? Well, it's also 180 degrees. Okay, this is leading us to a new rule that I think you're going to appreciate. It makes things much easier. So w plus z equals 180, and so do the three angles in the triangle. So that means, you know what that means? That means these three angles right here, since they equal 180, equal these two angles. So w plus x plus y from over here must equal w plus z. Okay. Now, you might be wondering, what am I going to do with this? Well, let's see. What do we have in common on both sides? Do you see it? There it is, w. Both sides contain a w. So let's subtract the w and see what's left. Okay, well, these w's cancel out. These w's cancel out. And we have x plus y equals z. All right, let me show you what I was driving at here. So this exterior angle that we were talking about earlier is equal to these two angles. These are called, when we're talking about triangles, these are called non-adjacent angles. Again, adjacent just means ones that are next to something else. So here, W is adjacent to Z. See, they're right next to each other. But X and Y are not adjacent to Z. They're on the, well, for lack of a better word, they're on the other side of the triangle. So there's a new rule for you. It's X plus Y equals Z. The two non-adjacent angles in a triangle are equal to the exterior angle. All right, I think I have another slide for that. Yep, here it is. So again, the measure of an exterior angle, like this Z right here, is equal to the sum of the two non-adjacent interior angles. So X plus Y is going to equal this Z. All right, so let's try one out. Okay, so here we go. Here's our exterior angle. So that X is equal to the sum of the non-adjacent angles. So 30 plus 25. Now, what angle would have been adjacent to X? Well, it would have been right here. So we're not going to use this angle at all. It's these two non-adjacent angles. The sum of them equals the exterior angle. Well, that's a pretty easy addition problem. X equals 55 degrees. So this angle, this exterior angle out here is 55 degrees. All right, let's move on. All right, here's another one I highlighted for us to do. So again, our exterior angle, X, is equal to the sum of the two non-adjacent interior angles. So X is equal to 40 plus, and here's why I picked this one. Again, we have the box. Do you remember what that equals? 90. Okay, so again, we have an easy addition problem. 40 plus 90 is 130. So there we go. Our exterior angle is 130 degrees. Not too bad, right? Now this one I'm going to start, but I don't think I'm going to finish it. I'd like my students to, you know what? Let's do the whole problem. This is the video going on YouTube, so let's just do the whole thing. So we have our hanger here, and we're going to figure out what X is, what our angles are. So we have X plus 110. And what do those three angles inside of a triangle have to equal? 180. All righty. Well, X plus X is 2X plus 110 equals 180. Subtract the 110, and we get 2X equals, well, 180 minus 110 is 70. Divide by 2. 2's cancel out, just like these 110s canceled out. And half of 70, 35. There we go. So what's the value of X in the clothes hanger? There we go. It's 35. And since it's an angle, it's 35 degrees. Okay, I'm skipping these. And here we go. Here's another one I wanted to try. Number 5. Tell whether a triangle can have the given angle measures. Okay, so can a triangle have these three numbers for its angles? If not, change the first one so that it does form a triangle. Okay, so we have to add these up. Now, I don't want to make this video last forever, so let's just use the calculator. So 36.9, 36.9 plus 110.4. Oh my goodness, let's start over. 36.9 plus 110. I did it again, didn't I? 110.4 plus 33.7. There we go. 181. Okay. Does that form a triangle? No. We know this is supposed to be 180. So this is 1 degree too much. Now, what did they say to do? If not, and this is not, change the first angle so it does form a triangle. Okay, so we have to change the 36.9. So if this is 1 too high, this number needs to be lowered by 1. So it looks like 35.9 would be the new angle measure. Okay, there we go. And I'll leave this one for my students to do. Here it says to find the value of x for each triangle. Now, as you can see, it looks like they're all basically the same thing, just different sizes of isosceles right triangles. So here we have a 90-degree angle right here, plus 45 plus x equals 180. So that's 135 plus x equals 180. All right. If we subtract 135 from both sides, yep, that's 45. Okay. Now over here, so this x right here is 45 degrees. All righty. Now here we have 45 plus 45. So 45 plus 45 plus x equals 180 again. So this is 90 plus x equals 180. And 90 plus what is 180? Well, 90. Oh, well, of course it is. Sure, because this was 90, and now we're seeing that right here from our math that this is also a 90-degree angle. And it looks like we should already know what this is, but we'll do it anyway. So again, we have 90 right here plus the 45. I'm sorry, plus the x equals 180. 90 plus 45, we already know that's 135 plus x, oops, forgot my zero here, equals 180. And oh, we have the same problem again as back on the first blue one here. So yep, once again, x is 45. All right, so that's interesting. It looks like isosceles right triangles always have a 90 and two 45-degree angles. It doesn't matter how big they are. All righty. So that's interesting, and that'll help my students answer these other questions. Do I have anything else? Oh, sort of a summary. So once again, x, y, and z here, the angles inside a triangle must add up to 180. Here was the other thing we did is the external angle. Whoops. Our exterior angle here, in this case I called it D, must be equal to the sum of the I'm going to put a plus sign here. We're going to add these non-adjacent angles. Okay, so in this case, D equals A plus B. And oh, I gave myself one more to do. I think this is the last one though. Oh no, I have two more. Okay, so let's look at this one right here. So in this case, it would be x plus 90, right here, that 90 is, equals 180. That gets me 2x plus 90 equals 180. Okay, subtract the 90 from both sides. And we have 2x equaling 180 minus 90 is 90. Divide by 2, and looks like x is 45. So find the measures of the interior angles. So it looks like each of these angles are 45 degrees. All righty, and one more. Gonna end on a tough one. So here we go. So this is where our two non-adjacent interior angles must be equal to our exterior angle. All righty, so it looks like our z plus 50 must equal z plus 10 plus 4z. Okay, let's start simplifying. I'm going to leave this side alone, z plus 50. But over here, let's see, I've got 1z plus 4 more z's, so that's 5z plus 10. Now let's see here. Which way should I move my z's to solve this? I think I'm going to subtract z from both sides. Okay. Those cancel out. So now I have 50 equals 4z plus 10. All right, we're getting closer. Let's subtract this 10 to get the z by itself. All right, those cancel out. 4z equals 50 minus 10 is 40. Oh, there we go. Oh, look at me. I'm changing my z into an x. Sorry about that. Didn't mean to confuse anybody. So there we go. 4z equals 40. I should have remembered that it was a z. Let's see. So 4 times what is 40? Well, it's 10. So z equals 10. All right. So I know what z equals, but now it says find the measure of each angle. All right. So here it would be 10 plus 10. Okay, so this angle is 20 degrees. This one says 4z. Again, z is 10, so 4 times 10. Okay, so this angle is 40 degrees. And over here, this was z plus 50. So that would be 10 plus 50, which is 60 degrees. Okay, so this is 20, this is 40, and this is 60. Now, does that follow the rule I talked about earlier? Remember what it was? The sum, so adding up these two internal non-adjacent angles, so 40 plus 20, has to equal the external angle, which is 60. Oh, and it worked. Look, 40 plus 20 does indeed equal 60. So there we go. That did work out. Well, guys, I hope you found that helpful. Thanks for joining me, and we'll catch you on the next video. Maybe another one about triangles soon. All right. Take care, guys. Bye-bye.